So basically network scanners, just looking at what the network is doing. Okay, so one example, this is a packet sniffer. Okay, who's used a packet sniffer before? Well, if I had the class to where I had it laid out a little bit differently, I'd assign you to do a packet sniffer. Okay, on your personal network, of course. Alternatively, feel free to go in the lab and use a packet sniffer plugged into the network within there, not over the Wi-Fi, of course. And why do I say that? Why shouldn't you use a packet sniffer on a corporate network? Okay, how many of you guys work for the IT department? So Paul told me quite a few of you. Okay. So, do you think the IT department would like me telling you guys to run a packet sniffer on their network? I'm not kidding. I suggest strongly against doing that on a corporate network. For one thing, it's quite easy to tell that it's happening. For another thing, could land people in a lot of trouble. Not me, because I'm not the one doing it. Okay? But I don't want to see you get in trouble. Like I say, it's a cool thing to see, though. There are certainly legitimate uses for them. So, skip talking about IPS and all that. Whole section in the book about it. I was joking earlier. Seems like they just kind of copied and pasted it about 4 or 5 times. It's like half the book, but that's a joke, of course. Port scanners, stuff like Nmap, we're basically just looking through, seeing what ports are open, seeing what we can pass across them, all that sort of good stuff. So lots of different things we can do with a port scanner. It's going to be something we'll definitely do next semester in information security. Personally, I view it more as a security topic than a network topic, but that's my opinion. You may feel differently, and my advice, if you feel differently and you want to use a port scanner, you can either do it at home or come to the lab and do it, somewhere else. Just be careful, because again, that's another thing that could get you in trouble. Wi-Fi analyzers. It's going to be quite common on Android devices to be able to download like a Wi-Fi analyzer app and see all the different frequencies, see which SSIDs are broadcasting, see which access points are broadcasting as well. Because as we know, access points, typically if they're enterprise, they can have how many different SSIDs? Most of them. Okay, most of them can have 8 on a single access point, right? Now, what's the downside of having 8 SSIDs versus having 1? Someone throw me a downside. No right or wrong answer. Well, actually, there are some wrong answers, but several right answers. That's a better way to put it. Performance going to stay the same, ceteris paribus. Who says performance stays the same? Okay, who says it's different? It's going to be a little bit degraded. Okay, because you're broadcasting the SSID, you got to devote a radio to doing that. If you don't devote a radio, you have to switch back and forth. So, certainly there's going to be some performance degradation. In general, I would say that with modern hardware, anything the past 5 years or so, maybe 7, it's not going to be that noticeable with a handful of SSIDs. So for instance, who can tell me how many SSIDs Fort Lewis uses? I have no idea personally. How many do they use? What are they? Okay, Fort Lewis, is that like for general devices or campus owned or 802.1x? Well, if you sign into it with your Fort Lewis account, 802.1x. Okay. Is what? Like media devices or what? Because not everything supports 802.1x. Okay. Interesting name for a network, I guess. Do they have a separate residential network here? Interesting. So, sounds about right, I guess. I don't know. There are very few places that are going to be using 8 separate SSIDs on a single access point. And I would hesitate to say that every access point can support 8. Certainly some can support many more than that. Okay, you get into some of these high-end access points that are, thousands of dollars, possibly even tens of thousands of dollars for a single unit. Yeah, you better believe they can support more than 8. Okay, they can support more than 1,000 simultaneous users. That's mostly for high-density areas, of course. So, what's another downside? Talked about performance. Who wants to maintain that? It's going to be more complex. It's going to be a little bit trickier. I mean, it's not impossible. I'm using 2 SSIDs at my house. It's not impossible. I have a IoT SSID, and I have the one that's tied to my standard wired network. Not that difficult to maintain, but it's more challenging, certainly. I think everyone would agree with that. Network segmentation is a good thing, though, is it not? Okay. Who trusts IoT devices? Who distrusts IoT devices? Okay. Why do you distrust them? For one thing, we know they're chatty devices, right? Sending out lots of communications all the time, right? Okay, we can certainly see that pretty easily. We don't necessarily know where that goes. We can see what the information that it's sending out is, but in terms of, having the sort of knowledge of what specifically is going on, we don't necessarily have that. Okay? So when we sort of think about things, it's not so easy to say whether we trust or distrust a device. You segment it, you don't have to worry about it though, right? Okay? So imagine that we had a network and we had devices that were maybe a little bit malicious. Okay? Put those on a separate network, not a problem, is it? So that's talking about Wi-Fi analyzers a little bit. Bandwidth speed testers, we talked about those. What do they do? Not a trick question. Bandwidth speed testers. Ben, what does bandwidth speed tester do? Yeah, exactly. Could be several more things, but that's the gist of it, okay? Certainly not a trick question. Okay, so the baseline. This is a sort of topic we go into a lot of detail about. Basically, all you're doing is you're saying this is the performance we expect based on the equipment we have. So for instance, let's say that we had some really old equipment. Okay, we used a lot of unmanaged hubs. I don't know why we would, but let's say we did. And each of those hubs had the ability to support up to a 10 megabit per second connection. Would we expect each of those connections to be able to simultaneously have a 10 megabit per second connection? Absolutely not. Okay, we'd have horrible network performance, would we not? Okay, it'd be sub-dial-up speeds. That's not very fast. Let's say we have modern networking equipment, not anything incredibly fancy, but let's say we have managed gigabit per second switches. Okay, would we expect to have substantially better performance? Okay. So you document what you have, sort of figure out what you expect to have in terms of speed, and that can sort of cue you in if you have issues where you're facing, maybe packet loss, stuff like that. You're going to have an idea of whether or not you should. And if you have a nice big list of all your equipment, what else does that mean? It means you can see stuff like firmware updates, right? Okay. It's very important to have this documented somewhere. I personally would advise that you automate what you can. It's not always good to automate though. Okay, let's say that there's a bad firmware and you roll it out overnight to every access point you have. Okay, People come in the morning, what happens? They're not connecting to anything, are they? Okay, so that could cause some problems. So my advice would be to having a testing environment, of course, test everything pretty thoroughly, and then automate the rollout. Does that make sense? So I would certainly hope that whatever environment you end up in has the funding to have a testing environment. Pretty basic thing, okay? Like I said, it's something that's commonplace for a reason. Updates happen, sometimes they break things. It's kind of like topology, not exactly though. So topology is more like the layout. This is more like what we have, what we expect to receive from it. Now, could you include a topology inside of your documentation? Yeah, absolutely. Should you include a topology inside your documentation? Of course. Okay? Topology is going to be sort of like a physical thing. And in fact, most wireless controllers, they can build that out automatically. You know? Sometimes you have to enter your building layout manually. Sometimes you can estimate it reasonably well. Because let's face it, you know, interference, that's predictable, is it not? Is it 100% predictable? No. Is it pretty close? Yeah, incredibly close. Okay. You know, you can reasonably estimate how long a cable is. Talk about that in a little bit. So that's pretty basic stuff there. Network monitoring is going to be pretty important for several reasons. Let's say an employee is accessing content they shouldn't be accessing. Okay, maybe they're going to websites that you should be 18 or older to enter. Okay, I'll leave it to your imagination what that may be. Okay. Now, if that's happening at work, that's a big problem, is it not? Okay. I don't need to go into details about why that's a problem. It should be self-explanatory. Network monitoring will be able to inform people that it's happening. You know, give real-time alerts, certainly give historical information. Pretty basic stuff there. This can be done in a lot of different places. Okay, so for some reason I said most likely built into the, it is probably built into the router to log stuff, let's be honest. Where are you more likely to use it though? You're more likely to use it on the router or somewhere else? You're probably going to be able to make a pretty strong argument that firewall may be a better place to do it. It's up to you. Okay, I'm not telling you where to put anything. So there's a lot of reasons to do this. I think that the main one is just making sure that you're not leaving yourself open. If you don't log anything, you don't know what happens. How can you have an IDS if you don't have logging? You can't. Okay, so you got employment. We talked about that. Legal reasons. Certainly there are going to be some legal reasons. I'm not going to say whether they're good or bad, but let's face it, a lot of stuff is required to be logged by the government. Okay? And again, I'm not here to say whether it should or shouldn't be required. I'm just here to say it is. Okay? You tell me whether or not you think it should be required. Actually, don't tell me. Load testing, throughput testing, other ways to think about this, okay? So, network monitoring, it's not just, sort of seeing who's visiting what, okay? It's also seeing how the network is doing. Okay, pretty self-explanatory. All right. So, next we have simple network management protocol. Basically, it's just a basic protocol to sort of be able to exchange messages across in a standardized fashion. So, specifically, you're going to be communicating with the network management stations. In 2021, if you're going to be using this, don't use anything other than SNMP3. Okay, anything prior to that, it's not going to be encrypting the authentication. So what's the point of having authentication if I can have a packet sniffer going and get your credentials? Is there any point? Is it going to keep out anyone if they want to get in? To me, that's kind of like having a door, okay, and the door has a lock, okay, but you leave the key under the mat. Okay, someone walking by, if they don't think to look under your mat, maybe that'll keep them out, right? Now, If you're a burglar, which I hope you're not a burglar, I think I said I don't like criminals, but imagine someone were a burglar. You think they're going to look under your mat if they want to get in? I think they would, okay? So why would you not encrypt this? I don't know. Syslog is another thing. Basically, it's just going to be a protocol to store logging files. So most of the time, it's going to be something on like a firewall, router, or switch. Could be other places, of course. Like I said, it's a standardized protocol. And basically, you can have all your different logs. You can put this on a server if you wanted and have it all in one place. You'd be able to sort through them, maybe do different filters. Certainly you could search. Lots of different options there. Cool thing is that it has a standardized sort of approach to how it's going to prioritize things. So it goes all the way from emergency, which is like the network is down, all the way to debugging, which is like don't even worry about it unless you're worrying about it. But anyway, we also have security, information, and event management. Basically, this combines two things. It's going to combine security information and event information. Okay, so pretty self-explanatory with this one. Of course, this is also going to be real-time and historical. It's going to allow us to do a lot of different things with this data that it collects, of course. Dashboard formation could be important. Data collection, alerts, compliance, any of that sort of stuff. They're really self-explanatory. Not going to go into that too much. Okay, so hardware tools. If I had more time this morning, I would have brought some of these, but I'll tell you what, I got behind some really slow people, including a school bus that stopped for like 5 minutes. But can't legally pass a school bus, can you? Okay. And again, I'm not here to say whether that's a good or bad law, but it's a real bummer when you get behind a school bus, is it not? So anyway, I didn't have time to get any of this stuff, but at least I made it here on time. So there's that. The good news is we've used this stuff before, right? So you've seen it. Okay, you got cable testers. This can be for analog cables, of course. Or it might also be for digital cables. So digital cables would be things like fiber optic. Analog cables can be things like, let's see, copper. Okay. So can you pass a digital signal through copper? Yeah, but most of the time, kind of signal we're passing through it, or at least a lot of the time. So it's really not one that I would say yes or no to. So that's basically a cable test. It's going to tell you if the cable works, basic level. And I will also say a lot of these tools can be in a single device. Okay, so you may have a Fluke cable tester, and it may be able to do everything. Okay, that's very possible. Now those are nice devices. Okay, I don't have a big budget. Okay, so we bought not so nice devices, but they work. Okay, so that's what's important, right? Crimp tools, obviously that's going to be used to put an end on a cable. I think that's pretty self-explanatory. Pretty inexpensive for RJ45. A little bit pricier, not much, for coax, and then like extremely pricey for fiber. Okay, so the fiber cable itself not that much more expensive. In some cases, it may even be less expensive for getting the same spec and all that. The ends and doing all the termination and splices, that's where it gets really pricey. Talk to Nick sometime, or talk to Brian. They'll tell you how expensive that equipment is. You get good stuff, it's going to be tens of thousands of dollars for fiber. Okay, good stuff for copper is like a couple $100. Does that make sense? So, quite pricey. Splice tools, yeah. If you want to splice into a connection. Most of the time you're not doing that with copper. You certainly can. It's possible. It's more likely you're going to be splicing fiber, though. A lot of different reasons for that. Most of the time, just think about where they're going to be used. Okay. If you're doing a 300-foot run in a commercial building, you're not going to want to continually, run new cable. I think that makes sense. And most of the time, for obvious reasons, you would probably do a 300-foot run with fiber. Okay. main reason for that being that with fiber, it's not going to be subject to any sort of interference. About the only time you can really interfere with fiber is if you took off all the insulation and shined a big light on it. Okay. Now, who on earth would do that? Is anyone going to do that in here? Why not? Why are you not going to rip all the insulation off to shine a big light on fiber? Because it wouldn't be a good idea, right? I mean, you're going to have, that would introduce interference. It would take a lot of time to do that, for one thing. You would probably, to be honest, you'd probably end up damaging the fiber. Even if you didn't, I can't think of any reason why anyone would ever do that. Okay? If you're going to sabotage it, why not just cut it? Why would you sit there and whittle away all the insulation? I don't know. Can anyone think of a good reason to do that? I can think of one good reason. Now, hypothetically, and I'm not offering this, hypothetically, if I were to bet someone they couldn't do it, then that'd be a good reason to do it, would it not? Because then there's money involved. Okay? I don't like to lose money. Okay? I'm not ever going to make a bet I don't win. Okay? Why do I not like to lose money? Okay? Because I'm not an idiot. Okay? Does that make sense? Now, I'm not saying people who lose money are idiots. I'm saying I don't like to. If you like to lose money, that's not a good business decision. Okay? It's a school of business administration, right? Okay? Don't make poor business decisions. Supply still talk about that. Loopback adapter. Just a device that makes sure the port is okay, basically. Okay. So you have a port, you're not sure whether it's working or not. Plug a little loopback adapter in there, tell you if it's working. Okay. Wire map tester. This is like the type of device we have, where all it's doing is it's sending a signal to each of the different, not the pair, but the individual wire on each end, one at a time. You know how it had the lights go down and do that? It's like the worst type of cable tester there is. Okay, but it's also the cheapest. So, I'm kind of the opinion if it's cheap, it's good. Okay, so if it's the cheapest, it can't be the worst, right? Because it's good. Is that solid logic? Well, it is in fact the worst type, but if you're buying one and you're not going to be using it very often, why not cheap out? That's what I always say. But you didn't ask me what I said. Continuity tester. All this is going to do is just test the cable to make sure there's no breaks. And it can also look for stuff like signal degradation as well. Well, let me rephrase that. Good ones can look for stuff like signal degradation. Okay? You get a bad one like something I'd buy, well, it's not going to tell you that information. But you also have to remember, I'm not an internet service provider, am I? Okay? I'm not providing internet service. I don't need to have, a good toolbox or good tool set. There's no need for me. Now, let's say that you're working for a company and you're managing, a company's network. And for whatever reason, you're buying network testing equipment. Should you cheap out? Why or why not? Who has an opinion they want to share? Go for it. Yeah, so if you have, a cable with some attenuation in it, okay, what's going to happen over time? Is that going to go away, or is it going to get worse? Probably going to get worse. And you can tell that, and you can correct it early on, but it's just going to make things worse over time. So I think there's a lot of reasons to not cheap out if you're working for a big company. Now, you got a small company, does that change things a little bit? Okay, so you got a small company, probably a smaller space, probably easier to work with the physical connections, probably easier to get to everything. Maybe it makes sense in that context to cheap out. Okay, because for one thing, smaller companies means what in terms of budget? Is it going to be a bigger budget or a smaller budget, ceteris paribus? Smaller. Okay, they're a small company. There are very few small companies, I'm talking like a handful of employees, For one thing, there's very few small companies that would even have a dedicated IT department. Okay, typically that's not something you see until you get to around 50 employees. Okay, you could, and most of the time though, they're going to get service through like a managed service provider of some sort. Hopefully a good one. Okay, not all managed service providers are created equally. So certainly make sure you're getting a good one that's going to work well with you. Certifier, really straightforward. You got a cable, has a certain specification, most likely provided by ISO. All it's going to do is just test it to make sure that it meets that. Okay, does that make sense? All right, hardware tools. We've talked about some of these. Basically, we have the time domain reflectometer. Okay, I might have mispronounced that. Maybe you can correct me if I'm wrong. If you're an expert pronouncer, maybe you want to pounce on my pronouns. Okay, that's a bad joke. Basically, all it's going to do is just tell if there's faults in wires. And when I say wires, I'm not talking about any old. I mean, a wire is going to be something not necessarily made out of copper, made out of metal. Okay, I would make an argument that the fiber strand is not a wire, because to me, a wire is passing what type of signal? It's passing light, or is it passing electrical signal? It has an electrical signal. That's my opinion. You can disagree if you want. That's fine. But basically, it's going to tell you stuff like how fast the cable can transmit. If there's any sort of latency issues, stuff like that, where packets are going across slowly, maybe there's a delay for some reason, it can tell you that information. Another cool thing is that it can tell you the length. Okay. Not only that, if there is a fault, it can estimate at what point the fault is in a lot of contexts, not every context. So not all TDRs are created equally. Some of them are better than others. Okay. But the good ones can tell you the length, and they can also tell you if there's a cut or something like that and where that is. Now, that's going to be a lot more important on the optical TDRs, okay? So TDRs are for wires. What do you think opticals are for? It's on the board here. Okay. Fiber optic. So anything that's not a wire. Well, I wouldn't say anything. Anything that's using a light signal, right? Okay, so it can do the same stuff, but this is vital if you're an internet service provider and you got fiber that you're laying, okay? It's vital. Because let's say a backhoe comes along doing some road construction and they chop the fiber in half. Okay, do you want to know where that chop is? I think you would want to know where the chop is, right? So it can certainly tell you that information if you have a good one. Now, is it going to get it down to the exact foot, the exact inch, the exact 32nd of an inch? Of course not. It's going to give you a really good idea, though. So, in this context, you got 7 miles of fiber run. Let's just use this as an example. Okay, so you got a 7-mile run of fiber. You got a break right here. If you can get it to right around here, is this a lot easier to search for than from here to here? Yeah, a lot easier to search a relatively small area than a huge area. So they don't have to be 100% to be useful. Okay. Not to mention, you may not even know where the fiber is. This can tell you. Okay, multimeter, really straightforward. It's going to allow you to test a variety of things with an electrical signal. Most notably, in the context of networking, it's going to be wattage, of course, because for stuff like PoE, it's possible you may want to test that. Resistance could be important. Most multimeters can test resistance. Definitely could look at voltage. Don't know why you would in networking, but just know that it exists. Toner probe generator, talked about those last class. Apply a tone to a cable, get a little probe, and listen for the tone. Okay, really straightforward. Punch down tool. We kind of had them in, I think they were on our wire stripper we had. So basically, the idea is that you have a patch panel. Okay, you use a punch down tool to, basically firmly and securely attach the individual strand to the patch panel. Same thing if you ever run ports. So for instance, if you were to run a cable, and instead of just running the cable, maybe you want to put like a nice fancy little port like we got over here, you could do that. Okay, you'd have to punch down, of course. Now, you get a good one, it's going to tell you the insertion force. Okay, so you're not going to over punch or under punch. What happens if you under punch? Is it going to come loose and not work? Probably. What happens if you over punch? Okay, wouldn't come loose, but it wouldn't work. Okay, you smushed it. You don't want to do either of those things. Okay, it's a cable stripper, also referred to as a wire stripper. Okay, it's going to be pretty self-explanatory. Removes the insulation without damaging the wire itself. Okay, it looks like this little guy's a little bit nervous talking about strippers, isn't he? Okay, environmental monitors. So environmental monitors can be really self-explanatory. It's going to tell you stuff like heat, humidity, maybe other things. And a lot of times it's going to be built into whatever sort of alarm system you're using. Okay, so it's going to notify you potentially. It's going to set off alarms. It's just going to be built in, and it doesn't have to be built into an alarm. It can be a standalone system. There's no real only way to do things. So pretty much wraps it up. Like I said, it's a shorter lecture today. Give you all a little bit of time on Friday. Figured that'd be nice. So yeah, just talk about hardware tools and different tools and stuff. So 2 more lectures, and then it's labs from here on out. Any questions? All right, have a good one, everyone. See you on Monday. Have a good weekend.